This is Chemistry Unit 11, Energy. Energy is defined as the capacity to do work or produce heat. And we can look at energy in the same way that we look at matter. It's conserved in a reaction. So the law of conservation of energy must be observed along with the law of conservation of matter, in which neither are created nor destroyed, but conserved. So the total mass and the total energy of a system remains constant. So what do I mean by system? Well, when we look at energy, we can look at it in terms of the world we live in, right? Or our universe. So we usually say there's two parts to the universe. We look at what's called a system and then the surroundings. So the system really is the part of the universe that we focus on or study. And for chemistry students, it's usually a chemical reaction. And the surroundings are the rest of the universe that interacts with that system. And this is a great visual for you to check out as well to help you understand the difference. Heat flow. So heat is energy that is transferred from one object to another because of a difference in their temperatures. And heat flow usually accompanies all physical and chemical processes that occur within the universe. Now, the direction of that heat flow is usually from a hot system to a cold system. So usually the hot system has more energy and the cold system is trying to acquire that energy. So the heat flow usually travels from a hot system to a cold system. And if you'd like to check out this video from Bozeman, who has a great YouTube channel with a lot of subjects, not just chemistry, but nonetheless, this is a 5-minute video where he discusses heat flow. He shows some great visuals, and then he also references this PhET simulation if you'd like to try for yourself. How to manipulate energy and heat with different objects. You are welcome to try. This video and this simulation will be posted for you. Now, the direction of heat flow will be represented with the letter Q and also a positive and negative sign. So, Q is chosen, I think, because it hasn't been used elsewhere, but I really don't know why Q was chosen. I can just guess why H or HE was not chosen to represent heat. I think that's too confusing with the elements hydrogen or helium. Also, H is referencing Planck's constant, which we learned about earlier. So another letter was chosen just to eliminate confusion, but I really don't know why it was Q. But nonetheless, Q represents heat flowing into or out of a system. Now, the into or out of a system is represented by a plus or a minus sign. So when Q or heat flow is positive, it's positive when the heat is flowing from the surroundings into the system. So we call this endothermic. So think of endo like entering, endothermic. Good example is one of those disposable ice packs. So there's really no ice in the ice pack. There's actually two chemicals that are sealed separately, and then when you break the seal and they mix, you feel that ice pack as something really cold. Now, why is that? Because the energy flowed into that system of those chemicals reacting, and you feel it as something cold. When Q is negative, when heat flows from the system to the surroundings, that is referred to as exothermic, like exiting, exo, right? So the heat is flowing to the surroundings from the system. And generally you feel this as something warm. So if you think about those disposable hand warmers, when those chemicals react, how does the hand warmer feel? It feels warm to you. So energy came out of the system of those chemicals reacting, and you felt it as something warm. We will also be calculating heat flow, and we will use this equation, which is quite new for you, so let's break down the parts. So it's Q, which is heat flow, equals M is referencing mass. So M probably sounds familiar, like from density and so forth. That's the mass of a sample, usually in grams. Now that triangle is actually the Greek letter delta. And you don't really have to call it delta T, you can, but what it really means is a change in temperature. So remember, heat flows from one object to another. So we need that difference in temperature. So it's really a subtraction. You see T final minus T initial. So you will be subtracting the initial temperature from the final temperature, and this will be in degrees Celsius. Now CP is referencing the specific heat of a system. Now I prefer to use the symbol CP because I think the other more modern symbols are a little too confusing, but they're not necessarily wrong. So other teachers or textbooks might use S or C, but I just think that's too confusing for seconds or Celsius. So I prefer to use CP. Yes, it's old school, that's my choice. But if you choose to use S or C, you are not wrong, but I will continue to discuss and use CP. Now, what specific heat is, it's the amount of heat that's needed to raise the temperature of 1 gram of a pure substance by 1 degrees Celsius. And you can see the units here are J, which stands for joule, that means energy, per gram degrees Celsius. So if you think of like aluminum foil, right? So it is aluminum foil, not tin foil. That's something else. So aluminum foil that you might have in your kitchen, or we use it here at school. So aluminum, right? Aluminum has a specific heat. Every substance has a specific heat. You can actually look them up. So what that means, it's the amount of heat that's needed to raise a gram of that aluminum by 1 degrees Celsius. So it's the gram of the substance by 1 degree Celsius. How much heat do you need to slowly raise the temperature of small amounts of a substance? Now, some substances have a high specific heat, some have a low specific heat. We'll get into what that means as we progress through the unit. So right now, just understand that calculating heat flow, we will use this equation, Q equals M delta T Cp. Now, something to remember, heat and temperature are not the same thing. So when you measure temperature, right, with the thermometer, what you are measuring is the random motion or kinetic energy of a substance. So we often like boil water in the lab or other substances. So what's going on when you're tracking the temperature of that boiling water? You are tracking the motion of that water, right? That's why it's bubbling and it's moving. So you are measuring that motion, that's temperature. Heat is the transfer of energy as a result of a temperature change. Okay, so these are not the same thing. So heat is also referred to as thermal energy or Q, and it's transferred from a hot system to a cold system.